This video will demonstrate how to do problem 9.3 in the textbook using ArcMap. First thing I want to do is set the coordinate system to some foot-based state plane coordinate system. We'll use the New Mexico West one. The next thing, we already have generated our CSV file, our comma-separated values. Just to review it, we open it up, add it to the map and open it up. And I can see that it's generating its own fields, which is okay. The one we made for AutoCAD didn't accept any preset field names, and so ArcMap itself is generating those field names for you, which is no big deal as long as we realize that field 1 is the point number, field 2 is the northing, field 3 is the easting, and field 4 is the elevation or the Z. So at this point, with the right coordinate system, I can just right-click on it on the table and display the XY data. The X field will be field 3, and the Y will be field 2, and we don't need the Z field for this 2D map. So I'll just go ahead and click OK, and OK the next box. Now I have my grid of numbers. I can label these, to make sure that I'm looking at the right things, the right points. Label them based on field 5, which is the description. Let's see what that looks like. It's A's. Yeah, it looks like all the columns and everything are good. I might want to even, as we did in AutoCAD, label include the elevation. So I can put an ampersand and field 4, which was the elevation, and an ampersand, and I'll put a single quote character return in here too. Let's verify that. Okay. So now I can check the elevations, and they all seem to check. At this point, I want to make sure that my extension, my spatial analyst extension, is working. So go to extensions. I'm not able to do any of the other procedures without the spatial analyst working. And so it is, just make sure it's checked. And at this point I can go to the toolbox and use the interpolation settings in the toolbox. And we talked about the different ones, but we're going to use spline. And we're going to generate a surface, just like we did in Civil 3D. The input point features will be those events, which are the points saved in the map and not in a separate shapefile. The Z value field, again, will be field 4. And the output, make sure I'm going to put it in my same folder. Problem 9.3 folder. Name is surf1. Without any extension, that'll produce a Mesri grid. It will leave all the rest of it to as the defaults. Click OK. Now that I have the surface generated, I can play with the symbology of it to make it look better, but really what I want to do is go and make the contour lines at this point. So if I go to the surface tools, there's a contour tool inside the surface tools in the spatial analyst. The input raster is going to be our surf1. put it in the same place in our problem 9.3, and we'll name it, I guess, P9_3 contours. I'll set the contour interval to what the book says, 10 foot, and OK. Now that I have the contours on, open up the attribute table, and we can see that the elevation is under the contour field. I do want to separate the index and the intermediate contour lines, so I'll add a field to categorize them. I'll name it index. It could be anything really, but I'll just make it a 2-length text field, and I'll populate them with yeses or nos. If I sort the contours ascending, every 10 feet is a contour line, and every 50 feet would be an index contour. So any multiple of 50, such as 400, and holding the control key, I can select the index contours. So I forget to hold down the control key. So 400 feet, 450 feet, 500 feet, 600 feet. Then I can calculate with the field calculator and just put in double quotes capital Y. Okay. And so all those selected. Let's get it. To be a little more thorough, I'll switch the selection and just calculate the rest of them with a no. That should do it. I'll clear the selection. Now I can use my symbology tab in the layer properties to categorize based on that index. I'll set the nose to a default thickness, which would be 0.7 points, and I'll make it a dark gray. I'll set the yeses to 1.5 points, add a black. The only other thing to do is label the contour lines and add the north arrow and scale to the map. So I'll just do the labels, and I'll label them. I don't want to label them all the same way, because I only want to label the contour ones. So I'll define classes, and the default class I'll set as a query, where index equals a yes. So now it'll only label the index contour lines, and I'll label it based on its contour. If I want to put a foot tick after it, I suppose I could do that easily enough by putting a single quote and double quotes, verifying it. And now I can have a little tick mark after my foot. Might want to add a mask, background mask, to that label so it can be seen easily. So I'll set that to a 2-point halo. One more thing, under the placement properties, I want it on the line and not above it, and parallel to it would be sufficient. So now as I zoom and pan throughout the map, I can see that the index lines are the only ones being turn off these other ones. Makes it look like a good map. My end map should include the points and the index contours. I go to page layout. This is where I'd like to set the scale. I think the book already defines a scale for it. 1 foot is equal to 100. 1 inch is 100 feet, so that's 1 to 1200. Looks like it's going to be needing a little bit more, maybe to 200, so 24. Let's see if that works. Not quite. Let's go 48. Let's try. That's 1 inch is equal to 1,000 feet. That's 600. Looks like that's an appropriate scale, so 1 inch is equal to 600 feet. Seeing that the grids are 150 feet apart, and that's 1,200 feet. The rest of it I'll leave up to you to insert your title and the north arrow in the scale and the rest of the margin area.